Hi, everyone. Welcome to our presentation. My name is Xinang Li.
My name is Mufeng.
So today we are presenting for our final group project. And in this project, we are trying to forecast the wind energy generated um for a utility company using some historical data, which includes the power generation from the wind turbine, the air temperature, the speed direction, and the wing's direction and the wing speed. So the first step we took was to get our data prepared. After we first skimmed through data, we found that there are some missing values. And we handle those missing values using the interpolation method so that we can prepare the data for our time series building. And so after that, we created our daily time series and we plotted out and used the Dickey-Fuller test to test for the stationarity. As you can see at the right-hand bottom side, the coefficient of Z-1 is significant, which means that this time series is stationary and we do not need to take a first difference. And after that, we are trying to find the relationship between the explanatory variables and our target variables. So we plot all the relationships out, and as you can see, in the first two variables, the ambient temperature and wind direction, there's no specific pattern that we can find between our target variable and them. However, for the wind speed variable, there's a pretty obvious uptrend going on. So it's quite obvious that wind speed is more related to our target variable. And we also did a test using the ARIMA 000 to find the significance of those explanatory variables. Although all the p-value shows that they are significant, but as you can see, the wind speed got the lowest p-value. And also in the later iteration process, we found that the ambient temperature and wind direction become insignificant. So we decided to just take those two out and focus on the wind speed. And Mufeng is gonna show you guys more on our model building and model selection process.
So let me just briefly go over our iteration process. So as Leo mentioned, we only keep wind speed as the only explanatory variable in building these modules. If you can recall from the previous slides, there's a significant positive spike at lag 1 in the PACF graph. So that's why we start with the autoregressive term, which leads to our ARIMA 100 module. All the all of the terms are insignificant in this module, and we have a reduced RMC. But since we still observe a significant possible spike in ACF residual, we decide to add another autoregressive term, which leads to our ARIMA 200 module. And still, while all the terms are significant, you can still see there's a spike which is negative in our ACF residual, and we were trying to address that with an extra moving average module, which leads to our ARIMA 201 module. It has the lowest RMC, but we can see that one of the auto-regression term is insignificant if we are taking a significance level of 0.05. So we are trying to remove one auto-regressive term, which leads to our final module of ARIMA 101. We are trying to use auto ARIMA to find potential better modules, but since auto ARIMA returns the same result, which is ARIMA 101, so we decided to stick with the module. You can see the relative RMC as we did iterate through the process. So ARIMA 101 does not have the lowest RMC. It achieves significance in all its terms, and its performance at white noise is slightly better than other modules. So we decided to pick this one for our final prediction. So This is forecasting using our final module. We use the data for the future 5 days to build a metrics for the prediction, and we will run the module based on that. Below you can see the point forecast for the 5 days after our time series, as well as a brief graph summarizing the trend. So this leads to the end of our presentation. Again, we want to thank you for your attention.